considered, cloud computing is an emerging trend in IT field wherein which it allows on-demand availability of computer services. Now, let me invite Ms. Chandini PM, the Department Coordinator of this webinar, for the welcome speech. Over to you, Mr. Chandini.
Honorable Resource Person, Mr. Anthony John, Principal Dr. Sujay CP, IQC Coordinator Dr. Shaji Mariam Vitil, Coordinator of Guruvachan Webinar Series, Sri Abdul Salam AM, dear colleagues, ladies and gentlemen. A very good morning to everyone present here. Today, I'm extremely delighted to welcome all of you to the third technical session of Guruvachan Webinar Series. With immense pleasure, we present the International Webinar on Cloud Computing. First of all, on behalf of the Department of Computer Science, R. Shankar Memorial SNDP Yoga, extremely delighted to welcome our very special speaker of the day, Mr. Anthony John. It gives me immense pleasure to welcome Dr. Sujay CP, principal of our college and the motivating force for all our endeavors. Here is a hearty welcome to our IKC coordinator, Dr. Shaji Mariam Vitil, for organizing this webinar, which has opened up multidisciplinary academic areas for discussion. Next, I would welcome coordinator of Guruvachan webinar series, Sri Abdul Salam AM, who encouraged us to conduct a webinar like this. This is a great moment for us as we have many faculty members and the students from within and beyond Kerala. It's my pleasure to extend a cheerful welcome to you all. I feel honored to welcome all the students and fellow colleagues for taking part in this webinar. Well, before this webinar begins, please allow me to briefly introduce Speaker of the Day, Mr. Anthony John. Mr. Anthony John has been the Head of Product Management and User Experience at Arena, a PTC company, since 2014. Mr. John leads the product management and drives innovation efforts for Arena's SaaS product lifecycle management product suites. He is an expert in product design, strategy, and user experience. He has designed and created numerous products that are compelling enterprise-class software for supply chain management. With over 20 years of experience leading software product teams across different geographies, he brings a passion for product design and creation. Prior to Arena, Anthony defined the product strategy and roadmap for Autodesk and Oracle products. Anthony holds a bachelor's and master's degree in computer science and is a pragmatic marketing certified product management professional. I'm extremely delighted and proud to reveal that this dignified scholar, Anthony John, is a friend and classmate of mine. Welcome you all once again to the webinar and hope that you will have a great time ahead. Now, I invite Ms. Hridya Ji, Assistant Professor of Computer Science, to chair this session. Thank you.
Thank you, Ms. Now, without further ado, we will turn the time over to Mr. Anthony John, our resource person for today's webinar. Over to you, Mr. Anthony.
All right. Thank you, Hridya and Chandni. You know, that was impressive. Thank you for the warm welcome, everyone. I really appreciate the time and you all dialing in today to listen to me talk about cloud computing. Really appreciate you all taking the time. So let me go ahead and share the slides first, and then we can get started here. Give me a second. Right, let me see. Let's see if you see that. Is that looking good on your side? Hridya or Chandni, can you confirm? I cannot hear you. You're on mute.
Yes, we can hear. The presentation also good. Go ahead, sir.
Okay. All right. Thank you. Appreciate that. Again, welcome everyone. Thank you for dialing in today, and thank you for everyone who worked today to organize this webinar. And hearty welcome to everyone. Anthony John, I know Chandni actually introduced me. What I will be talking about today is cloud computing and the fundamentals of cloud computing. You will learn by the end of the webinar, you should have a good understanding of the evolution of cloud computing. When did it start and what became cloud computing? What are the components of cloud computing, right? And what all put together becomes the cloud computing. Types, there are different types of cloud computing. We call them models. So different models of cloud computing. And of course, the benefits and risks associated with cloud computing. So without further ado, let me talk about a little about, Chandni talked about me. Pretty much, I worked for a few companies in the past. I run product strategy, product design, and product management. I create products. That's what I do. That's my passion. I worked for Arena from 2014 until now. In the past, I worked for Autodesk. Autodesk or AutoCAD, as you know it, the CAD company. And I spent a decade at Oracle Cloud Applications, crafting Oracle solutions for our customers. So let's see, what we're going to talk about today, right? In the next hour, you will hear me talking about the evolution. Where did it all start, right? What became the cloud computing? I'll touch on a little bit of examples, right? And of some of the applications that you use day in and day out, and how they become the cloud, right? Or how they are using cloud to their advantage. So we'll see some of those applications you're very familiar with today on your mobile phones and your laptops, or a PC that you have at home, and how you access them. And how cloud plays a big role in making it work on your computer. And from there, we will move into what is the cloud, right? And what are the pieces that become the cloud, or the pieces of the puzzle, right? Once we understand that, we will look at the biggest force behind the cloud and what is the most important element of cloud. And then once we understand the components and what is the driving force behind the cloud, we will try to define cloud computing. What makes cloud computing, right? And once we define it, then we will dive into the different types of cloud that are available to us, right? And in the market today, there are multiple types of models, that you can actually think about and buy and rent and all of that. And at the end, we'll talk about benefits and risks. And we will end with a QA session that allows you to ask me questions, and I will try to answer as much as possible. Don't mistake my accent. I'm a pure Malu. Was born and raised in Kerala. So Malayalati choichalum, I will answer, right? And I'll get you the answers. All right. So with that said, let's start, talking about cloud, right? The first question is, or the thing to remember is we are moving to the cloud, right? And how's your fear of heights? Anybody afraid of heights? Acrophobia, right? No? Or yes? Okay. All right. So you don't have to be afraid of heights. This is not about climbing the hills and the mountains and being on top of the cloud. Cloud is a marketing or reference term used to explain how things are somewhere else than where you are located. It is not really going up to the clouds, or these are not stored in space or in the atmosphere. All of these are pretty much happening on planet Earth, very much on the ground. So you don't have to climb hills, mountains, none of that here. Okay, so with that out of the way and our fears out of the way, we will talk about the evolution of cloud, right? And what happened and when did it all come about? Long time ago, when I say long time ago, we're talking about the 60s or 1960s when John McCarthy came up with the mainframe computers. IBM is the company that came up with mainframe computers. And the idea behind mainframe computers was these are large scale computers, that existed in big locker rooms or big warehouses under climate control. When I say climate control, we're talking about air conditioning so that the machines don't overheat. And they supported this model of jobs. When I say jobs, you would go to a terminal on the computer, type some commands, and that will start a job, that will execute a job on the mainframe. And once a job is done, it'll come back with the result. That's mainframes in a long time ago. And it allowed multiple terminals, not just one, more than one terminal. So multiple users could actually submit jobs. So there was a job sharing model, right? So multiple jobs shared the same large hardware that was available. From there, right, late into the 60s, we started seeing the arrival or the PCs, right? That's when IBM invented PCs. As you know it, PCs are the backbone of computing today, right? Every one of you has got a PC, be it in the form of your smartphones, and it's technically a PC, it's just a smaller form factor. It's much smaller, or a laptop, or an iPad, or one of those tablets that you are familiar with. They're all one form or the other of a PC today, right? And from the PCs in the late 60s to ARPANET, which is the backbone of our interconnectivity, right? Our internet, as you all know it, or as you call it back home in India, my data plan. That's what this thing is, ARPANET, right? JCR Licklider, right, who was working with the United States Defense, came up with this wide area network, right, which connected two parts of the country together. So I'm talking about the East Coast of America, right, which is, you know it as Miami, New York, Florida. All of those areas are the East Coast of the country, to the West Coast of the country, which you know as LA, Hollywood, San Francisco, San Jose, Seattle, Portland, all of those areas. So that's practically talking about, from an Indian perspective, you're talking about connecting Kerala all the way up to Delhi, right? And two ends of the country, connecting them together. And that research paved the path for the internet and the data plans that we use today, right? And from there, there was a new movement, meanwhile in 1970s, called virtualization. Virtualization was spearheaded by GE, General Electric, and MIT. MIT is Massachusetts Institute of Technology, one of the most renowned institutions in the United States for minting technology heads. They are very good. They're a very good college for technology. And MIT and IBM and GE put together this idea of virtualization. Virtualization centered around the idea of you have a hardware layer, and then there's a software layer, which used the hardware layer to resource it to multiple applications at a time, right? Different operating systems, different applications, and contained in separate layers. And that's what virtualization supported. And that caught on, right? Because you had these large servers which could have a software layer, and then that software layer portioned the hardware as needed to different jobs and different operating systems and different applications. From virtualization, we fast forward, from 1970s to late 1980s, that is 89 to 1991, when we got the first World Wide Web. Sir Timothy John Berners coined the idea when he was working at CERN. CERN is actually a nuclear research facility in Switzerland. And then when he left CERN and he came up with the idea of how to transport data on the very renowned protocol, as you all know it, when you type on the browser today, called HTTP, right? Hypertext Transport Protocol. It's based off of a simple model of server and client. There's a server sitting somewhere remote. That means, you're not sitting on the server and typing the command. You're sitting on a terminal or a PC, and you send a request through a cable to the server, and the server responds back with a message. And that's what Hypertext Transport Protocol was all about. And you can send a message, it'll respond back. How did that work over the cable? It was because of ARPANET. ARPANET paved the path for the development of networks, or in networking terms, we call TCP/IP, which is the foundation of today's internet and intranet. Anywhere you have cables communicating, cables that are being used for two different computers or the Wi-Fi, there is TCP/IP behind it. How did this all work? It all worked based off of, like I said, TCP/IP and this new concept called DNS. DNS is domain name servers. Every computer gets an IP address. It's a combination of numbers, 169 or 192, 169, whatever, right? A combination of numbers. These numbers are hard to remember. So how do you remember google.com today? You call it as google.com. You never call it as 76.182.92.32. That's not something that you refer to google.com as. So that name conversion is done by the server in the middle called DNS. When you send a request, google.com, the DNS server says, oh, you're looking for google.com. All right, let me convert that to its physical address, like your house number, right? And it'll pick up the house number and then take your request and send it to the house number. That's what's going on, right? And now how does it send it? It sends it over a cable through TCP/IP. And from World Wide Web, right? What came about is the biggest the two things that came about from World Wide Web invention is, one, HTTP, I talked about it. Two, the browser that you use, the Google Chrome, the Firefox, the Brave, the Safari, the Microsoft Edge, all of these browsers today was, the fruit and labor of Tim Berners-Lee. He created the browser and invented the idea of tokenizing the requests and responding to the request and painting it on a page that you call as a web page in the browser. So from there, in 1997, we fast forward from 1991 and from the birth of World Wide Web to 1997, where an Indian professor in the United States coined the term cloud computing. His name was Professor Ramnath Chelappa, and he defined what cloud computing meant. And I'll talk about it in the next few slides, what cloud computing is. But from 1997, fast forward to 1998, this is where I take pride in saying I work for the company that started in 1998 and built the first cloud software. Arena was born and started offering the cloud software that we have today in 1998. Fast forward to 2020, we got sold to this company called PTC, Parametric Technology Corporation, for $750 million. That's some achievement, for a company of our size, for getting sold for that kind of money. Now, from 1998 to 1999, if we fast forward, we come across a company that you might be familiar with, which is called Salesforce. Salesforce develops a customer requirements management solution. They have a software platform that allows you to develop cloud applications on, and they are a multi-billion-dollar business today. Fast forward from 1999 to 2006, what we see is Amazon launching cloud computing infrastructure called EC2 services, Elastic Cloud Compute, or Elastic Compute Cloud, I'm sorry, and simple storage service called S3s. So that is what we all know as Amazon Web Services, or in short, AWS. Now, a little bit about how big is cloud computing and why is it important for the future, right? In 2006, it was probably worth a couple of $1 billion, right? From 2006 to 2013, that couple of $1 billion worth of business grew to $80 billion worth, 80. That's a huge bump. And you would think that's a huge bump. Fast forward to 2020, that $80 billion grew to $219 billion. Again, more than double, right? Almost 3 times the growth. In 2021, when we close this year, cloud computing will be worth $250 billion. $250 billion is a lot of money. Now, it's a B, so that means $1 million is, is a lakh, right? 1 lakh, right? And that's what a million is. We call them a lakh, in American terms, and we call it a million. And 1,000 millions is 1 billion. So you can imagine 250 billion, how big that amount of money is. And in 2028, the prediction by analysts, in 2028, we're going to see this multiplied by 3 times more. That is, we're talking about $750 billion worth business that we will have in cloud by 2028. So that's a compounding annual growth rate of 17 to 18%, of give or take 20%. And that's why you need to pay attention to cloud, because most of the jobs that are going to show up in the next span of 10 years will be in the cloud. There is no going past cloud without knowing how big that market is. And why is it increasing? Because countries like the US, the UK, China, and of course, India is investing in the cloud, right? And you see a lot of government efforts to actually move everything to computers, right? And you go through all of these services today, they're all computer-based, right? And where are they all hosted? They're all in the cloud, right? They're all hosted by somebody, somewhere. And that's why it is important to know this, understand it, learn it, and find a career path in cloud. All right, so with that, let me talk a little bit about some of those very familiar applications that you will see in the cloud today. Let me get this thing out of the way here. All right, so let's start with the most familiar logos here, right? Today, I'm pretty sure some of you recognize all of these logos. YouTube, right? Very ubiquitous when it comes to video streaming today, right? And everyone is on YouTube, and everyone is actually a video creator, consumer, you name it, they're all on YouTube. And a short version of that, and if you don't have time for the long, 15-minute videos, TikTok is the place to be today, right? And every youngster and a lot of you are hosting one of those applications on your phone. You have TikTok on your phone. Snapchat, another example. A lot of you have it. WhatsApp, right? And we all communicate through that nowadays. Google Maps, I'm pretty sure a lot of you have used it to look up how to get from point A to point B using Google Maps, right? And when I move into some of the business applications, we are talking on this webinar and seeing my presentation through Zoom. Zoom is hosted on cloud, right? And talk about my company, Arena, right? And of course, we're in the cloud. And Euphoria, another product that we offer, again, on the cloud. OnShape, another product that we offer, is on the cloud and is actually CAD or design CAD on the cloud, right? It used to be a very computer-heavy application, which was used to be running on PCs, is on the cloud today. Microsoft Office 365, Google Mail, Google Suite of products, Instagram, Freshworks. Girish Mathrubootham was on the news very recently. If you followed the news, he took his company that he started it somewhere in India. I believe it was in Tamil Nadu somewhere, and he got it listed in New York Stock Exchange for $18 billion. That's a lot of money, right? And all of it is on the cloud. Freshworks, it's a CRM like Salesforce. Salesforce, Netflix, almost everyone has got Netflix nowadays. Netflix is actually a very big success story on the cloud. They were a CD lending company, right? And I was a subscriber when it started. They would ship you DVDs in physical mail. A mailman or a postman will bring a CD or a DVD to your house. From there, they are the streaming, house today when it comes to movies and videos that are produced by studios in Hollywood and Pixar and others. So you get the picture, right? And almost every other application you use today is hosted on the cloud. Now the question comes, now that you understand the landscape and the examples of cloud, the question is, what becomes the cloud, right? And what is the cloud? And to answer that, we have to understand the components of cloud and know what makes cloud, right? So let's start with hardware. There is no escaping that, right? No, physical computers are behind the cloud, right? No, somewhere somebody is picking up a physical computer, pushing it up to a rack. Now, when I say rack, it's a shelf, right? And I don't know if you have seen server rooms. Server rooms will have racks and vertical racks, and one after the other servers are put onto the shelf and connected up. And somebody is racking it physically, right? And that's physical labor, right? To do that, right? And then they're configuring it, connecting cables, doing all of that, right? And these computers are the computing power behind the cloud. It does storage. That means physically store the data. That picture that you just took on your phone just went up to Google Photos. That got stored on the cloud on a server somebody physically put up and connected, right? That little Instagram picture did the same, right? And the Zoom video that's getting recorded is doing the same, right? And so all of that's stored on a computer somewhere remotely in the cloud, right? What happens after that, right? On top of the hardware, I talked about virtualization, right? There is a layer of software called hypervisor, right? That virtualizes the software. So think about a big, right, room full of servers and stacks, right, of servers, right? And these rooms are ginormous. I mean, it is the size of 7 football fields or more, right? In most cases. And what you walk through is racks and racks of servers. What these servers do is they are all part of a big cluster, right? Think of it like a necklace, right? They're all chained together. They can all, be part of that one necklace, or they can also be that one bead of the necklace, right? One little pebble or a pearl of that necklace. That's what these virtualization server rooms are all about, right? All of these servers that are available to this hypervisor sitting on top of the hardware, right? And when, let's say, hundreds of users start using Instagram, right? And one computer spins up and starts using the computing power. And when it realizes there is not enough computing power to support hundreds of users, it starts spinning up all the other servers it needs as the job count, increases. So it'll start with one, and eventually when 100 users log in, for example, it might be using 10 computers. When those 100 users start trailing off, that means out of 150 stop using it, it'll bring down the servers from 10 to 5. When that 50 users go down to 1, it'll just spin down those 4 computers and bring it to 1. That's called elasticity of cloud computing, right? So you simply can spin up servers as you need them, use all the computing power and the hardware power, and when you don't need them, you spin them down. So you're technically optimizing on usage. Instead of just running one server all the time, When you need it, you bring it up. When you're done, you bring it down, right? So that's virtualization. And then storage. Of course, and you know this is physical storage we're talking about, right? So now your pictures are stored somewhere in the form of a file on a hard drive, right? In a physical hard drive. Most of the time, it is spinning media. Then when I say spinning media, we're talking about magnetic hard drives, that you are familiar with. Or in today's world, they are solid state drives, which are silicon chips, storing memory, right? And your flash drive is actually a silicon chip, right? Which stores files. But in most of the cases, when you go into a data center, like the picture you see on the left there, is actually a spinning media that was plugged into a storage device. From there to the most important element, all of these are important, but network is also important, right? Connectivity, right? And connecting these things together is a bunch of cables, switches, routers, load balancers, edge networking devices. In Netflix's case, CDNs, they're called content delivery network, because Netflix, for example, when you click on a movie, it starts playing immediately. How do you think that happens, right? And Netflix has got these servers that are spread across all of the planet, right? And all of the countries they operate, and even in the geographies that they operate, right? And they have a server closer to you, and they have special servers built called CDNs that actually transport the video on demand to you. And that's how when you point onto a video, it actually starts showing you a preview of the video very fast. And it's all about CDNs and network connectivity. So from the network, let's talk about the force behind the cloud, right? Connectivity is the force behind the cloud. And the connectivity that today, which I talked about earlier, is the internet, right? And the data plan on your phone, the data plan on your internet service. This is what makes cloud work, right? This is what makes cloud tick. Without this, there is no way to access your Instagram, your Facebook, your WhatsApp, your Netflix, your YouTube. All of that's a moot point. There is no point in talking about all of this because you cannot access them. So when somebody talks about cloud, the biggest and the most important thing to know about is connectivity, right? You need to be able to connect to that remote server sitting in some warehouse somewhere and serving you content. So when something is in the cloud, it means it's stored on internet servers instead of your computer's hard drive, right? It is not physically present on your laptop or iPad or your phone. It is sitting somewhere in the cloud. All right, so now that we understand, the evolution of the cloud, the examples of the cloud applications, what is cloud and the different components of cloud, and the connectivity that's important to cloud, it's time to define cloud computing, right? Cloud computing is nothing but an on-demand delivery of hardware, memory, storage, video, you name it, all of that. The moment you click that button, right, and on your keyboard, or click that mouse button, you are served with the content, right? That's what cloud computing is. And for the service that you use, you pay for it, right? And for Netflix, you pay a monthly subscription. For any other service on that, some of that is free. Well, technically nothing is free. If it is free, you are the product. Ask me why. I know it because I make products. If somebody is giving you something for free, remember, they are taking something back from you and you are the product. Instagram, if they're giving you something for free, they're taking data from you, right? And they're taking your pictures, they're taking your picture locations, they're taking data from you to track where all you went, right? And so there's no free lunch anywhere today. You have to pay for it. So coming back to cloud computing, instead of buying, owning, maintaining data centers, right? And to maintain a data center, you've got to have physical space. You've got to pay for it. That physical space has to be climate controlled. That means in air conditioning has to be available. That means power, right? And no usage. You have to put racks of servers, and you have to man those management of servers. That means somebody has to physically go in and then load those servers up, connect. When things fail, remove them, put new ones in, all of that, right? When you don't want to do any of this, that's when cloud computing becomes the biggest and the best answer, right? You just simply go to Amazon, AWS, and all these cloud vendors out there, and then just say, I would like to rent something from you, right? Technically, you don't buy anything. You just rent it, pay for it. When you're done, you take your data, walk away, right? That's what cloud computing is all about. And that's the appeal of the cloud computing, because it's so easy, right? And today's startups spin up cloud services in no time because they have the access to cloud computing services that are offered by all of these companies that are out there. So now that we have defined cloud computing, it's time to see what are the types of cloud computing. So let me start with types. You will hear this term being interchangeably used in types or modes. They both are kind of the same thing, right? But in general terms, we call it, models. I shouldn't say modes. I'm sorry, modes. Models of cloud computing. There are deployment models and services models, right, for cloud computing. And I will talk about each one of them in the next few slides one by one, but let's look at the deployment models. You have public cloud, private cloud, and hybrid cloud, right? No marks for guessing. Hybrid cloud is a combination of public cloud and private cloud, right? Just put them together, you get the hybrid cloud. Services, there is infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. Those are the models, and let's look at each one of them in detail. If I can get the slide to move, there it is. All right, public cloud, right? Now, this is one of the models available in deployments. What does this mean, right? In the public cloud, as it states, as the word states, it literally means everything is accessed over the internet. You get access to this by clicking on a public website like facebook.com, fb.com, youtube.com, netflix.com, right? And all of that, or using the specific apps those companies have designed. They are just apps, but technically it is doing the same thing beneath the app. It is just, a shell which serves you the same content. But what is the important factor to know? All hardware, software, and other supporting infrastructure. When I say supporting infrastructure, the cables, the connectivity, the power, the physical racking, all of that is owned and managed by the cloud provider. The cloud providers, like, for example, Netflix is one of the largest and biggest customers of AWS or Amazon's Web Services or Amazon Cloud, as you know it. Salesforce, right? And others are also on Amazon and other cloud services that are out there. Salesforce deploys its own data centers, so I shouldn't say it's on AWS. They do their own data centers. But Microsoft Azure is another cloud vendor that supports, same type of deployments, if you would like to have a cloud access. Moving on to the next model that's available to us, which is the private cloud. In private cloud, everything is accessed over the intranet. Intranet is not the same as internet. It is a private network. That means, hey, when you go to your college, and then if you're accessing a server within the college, infrastructure, that is a private network, and it can be talked about like a private cloud. It's not necessarily, there's a fundamental difference to on-premise versus cloud, but general terms, you are correct to access a service within your college server through a terminal or a PC connected to that server. is called a private cloud, and you don't have access to it from outside. The moment you leave the college campus, you don't have access to it. So think about it that way. We operate private cloud in our offices to make sure our employees have access to, files, services, code compilers, and others within the network of our office. The moment you leave the network of our office, you don't have access to the data center or that cloud. A private cloud can be physically located in the company's on-site data center or remote, right? Now you can actually rent a physical data center space and put your servers there and connect a cable up to your office. Yes, literally a cable up to the office, right? And no, it goes through underground pipes and under the roads that you ride on. There are cables, millions and millions of miles of it. And some companies pay third-party service providers to host their private cloud, right? No, you can actually go to AWS, VMware, or Azure, Microsoft Azure, to say, hey, I would like a private cloud. And what do? They actually go to their data center, pick a server rack, and then just say, does this help you? Oh, do you need more than one server rack? Now you can size it, and then once you size it, they will dedicate that hardware for you, and that's called a private cloud on AWS or Azure. There are ways to virtualize it too, right? And so you can practically, this is like buying something from a shop, right? And then you can just say, I want specifically select the bananas I want to buy. It's the same thing with the servers you want to buy. You pick and choose what you want to buy from these vendors. And a quick note about internet, if somebody tells you that internet is actually going through satellites, yes, it is going through satellites, but if they say there are no cables, do not believe them, right? There are cables everywhere on this planet. It is under the oceans, that's what connects, Kochi all the way to Singapore, Singapore to United States, or United States to Bombay or Mumbai or UK. Everything is connected through cables. They are called marine cables. They are on the ocean floor. And all of that request that you sent when you type google.com actually goes through that cable, right? The satellites, if you were to use satellites, and then you will be sitting there twiddling your thumbs and then just saying, I clicked google.com, nothing is happening. You see a spinning wheel. It'll take time for it to go through the air and come back, right? And even under Wi-Fi, right? And if you say, oh, Wi-Fi is over the air, right? And now until you reach the Wi-Fi router. From the Wi-Fi router, everything is going through a cable. So just keep that in mind. All right, so coming back to our deployment models, right? The hybrid cloud is a combination of both the public and private cloud, right? So some parts of the application or some applications are stored on the public cloud, and some of it is stored in a private cloud, right? A combination of things to support the use cases of different applications. Excuse me. And an example of that is in defense companies, right? And defense companies in India and in almost all of the countries have sensitive data they don't want to put on public cloud, right? So how do they actually work? They actually work based off of public and private cloud combinations called hybrid clouds. An example is ITAR. ITAR is actually an American standard for international traffic in arms and regulations compliance. And FedRAMP is an agency that certifies any cloud, whether it's worthy of adopting by the Defense Department of America. And you would have very similar organizations in India and in other countries around the world. So moving on from the deployment models to services models, right? Now we're talking about what types of services can you get on a cloud? The first one is infrastructure as a service. This is the most common service that you will come across. Infrastructure as a service is pretty much access to virtual networking and access to dedicated hardware and data storage. Technically, you're renting a PC sitting in somebody else's physical location. You're going to Amazon and saying, I would like to rent a PC from you. They're like, oh, great. Okay. what's the configuration you're looking for? Oh, I would like that much of RAM or memory, this much of storage, and 100 CPUs, computing power. And they will say, great, all right, and you pay us for that, right? And that's what infrastructure as a service is. An example is Amazon EC2. I talked about it in Elastic Compute Cloud. That's what Amazon services, and Microsoft Azure, and IBM Cloud, and Oracle Cloud. They all have very comparable infrastructure as a service offering. Infrastructure as a service gives you the highest level of flexibility and management control over your IT resources. That means they physically give you the hardware. Everything else is your problem. You have to configure it, and you have to configure the network. You have to configure the protocols. You have to configure access. You manage it all, right? And everything is done by you except for the physical hardware. Physical hardware is managed by the vendor. Now, if we move to platform as a service, this is one level above infrastructure as a service. It gives you access to an on-demand environment for developing, testing, delivering, and managing software applications. So think about, you're a company that would like to develop software, and you would like to develop it based off of a specific environment, right? And let's say, for example, you're developing software for Mac, and you would like to have an environment, that supports, Mac development. That's what you get, right? Or you would like to have a specific environment configured in a specific fashion. That's what you're getting as part of a platform as a service, right? AWS Elastic Beanstalk is an example. There are so many different jargons that I'm throwing at you. I'm not expecting you to remember all of that, but Beanstalk is an environment which allows you to do development, testing, and delivering and managing of software applications. The idea behind platform as a service is it makes it easy for developers to very quickly create web applications, mobile applications like the Instagram apps and Facebook apps that you have on your mobile, without worrying about the hardware and the software and the virtual machines and everything else that has to be set up. Right? Environment variables for Java and all of that. You don't have to worry about setting all of that up, and it's all readily available for you. All you have to do is just start coding and then testing things. And that's what platform as a service is all about. And then the last one, of course, is software as a service. This is another layer above it. So you've got infrastructure as a service, software, platform as a service, and then you've got software as a service on top of it. This is purpose-built software that is available for you to rent, right? Now, think about your Netflix. It is purpose-built for video streaming. YouTube, purpose-built for video streaming, right? And Instagram, purpose-built for pictures and short videos. TikTok, purpose-built for short videos. WhatsApp, purpose-built for messaging, right? And that's what this is all about, software as a service. All of those guys I just gave you an example of, they're all software as a service, right? Somebody built the software, you pay for using the software, and it's serviced by cloud, right? So in this setting, cloud provider like Amazon or AWS or Azure or IBM Cloud manages everything for you, right? And manages the software application, infrastructure, maintenance, whole 9 yards, right? And all the way from the infrastructure to the platform to software, they manage all of that for you. All you have to do is just deploy it, right? And now you create the software, you write the code, you test it, compile it, then you deploy it to that service. Everything else is managed by them. So you completely hands off, right? And now I'm not driving the car. I'm going to go sit in the back seat. Chauffeur, please drive me to destination B, right? That's what this is. This is the most luxurious option, software as a service. Now that you understand all the different, service models, it is good to compare them, right? And then understand how it is getting maintained and who maintains them. Right? On-premise, is on the left. That means, you buy your own hardware, you buy your own networking equipment, you buy your own storage equipment, rack it all physically, you maintain it, you hire people to do it, and then you do the whole 9 yards. That's why all of that is in white. The legend is on the right. No, white is maintained by you. The green is maintained by the vendor. When I say the vendor, think about Amazon AWS, Microsoft Azure, IBM Cloud, Oracle Cloud, VMware Cloud, all of these guys. You move into infrastructure as a service, half of it is actually done by you and half of it is done by the vendor, right? No, the networking, storage, servers, and virtualization, that means the physical connection and the physical part of it is done by the vendor, right? And they take care of that for you and you pay for just that. Everything above it, that means you got physical hardware, starting with the operating system, middleware, runtime, data, applications, all of that's done by you. So you have to configure the operating system, install the operating system, configure it. You install the middleware for your software interpretations and the compilers, everything else. Runtime like Java virtual machines, you install it. Then you create the data set, and then you create the applications that use that data set. All of that white pieces are maintained by you. Moving into platform as a service, you see that a lot of that stuff at the bottom is being maintained by Amazon or Azure for you, right? Application and data is maintained by you, right? And so you don't maintain anything else, so you just rent it, right? And the most luxurious option, SaaS or software as a service, everything is maintained by the vendor. You're hands off, you just give them the software, deploy it, and pay for all of it, right? And so that's the whole stack. Technically, this is what happens beneath the cloud computing that you are using day in and day out without knowing what's happening behind the scenes. Now, the question is, okay, if you ask me, Anthony, this is great. I would like to know, how do I actually use cloud computing, and how does that fare with the service that I'm looking for? The answer is one size does not fit all, right? And no, there's no way you can put that, square peg in that round hole. It's just not going to fit, right? It's the same with cloud. You cannot have a one size fit all solution for a cloud. So how do you size the cloud? How do you buy cloud? And how do you actually understand what you need to buy? The most important part of deciding what cloud to buy is based on purpose and requirement. What are you trying to do? And what are your requirements, right? And know what should your computer do for you. Once you understand that, then it's easy to define what cloud can you buy, right? For example, let's say you would like to rent a bunch of computers on the cloud. Yeah, it's easy. Go to Amazon, rent a bunch of EC2 instances, Elastic containers, and you're all set to go, right? And you pay for what you use and then just walk away when you're done, right? But if you're looking for storage, for example, right, in the cloud, then you should be thinking about renting S3 services from Amazon. That is actually a backup service. But if you're looking at archiving large amounts of data and storing them safely, right, and not using them day in and out, then you don't want, storage. You want archival, which is another service from Amazon called Glacier, right? So Glacier allows you to archive huge and vast amounts of data. We're talking about terabytes and terabytes of data in hundreds of thousands of terabytes, right? That's storage based in no cloud service. Now, network-based cloud service, if you'd like to have that, you could have VPC, which is virtual private cloud. Network, that's available from Amazon. Route 53, which is a DNS service from Amazon. So you can rent all of that, right? And if your service needs all of that capabilities, you could do that, right? Now let's think about, I would like my service to be pretty secure, right? And so then you would go rent IAM from Amazon Cloud, which is identity and access management. Technically, authentication, when you put in your password, username and password, it goes through that service, right? It actually uses specific protocols and it uses specific encryption algorithms and specific ways of actually deciphering is your password and username correct, and do they match, right? There is another service from Amazon called KMS, which is Key Management Services. So all of these passwords are, when you put into an application, are not stored in password that you type, right? And if you typed ABCD, or the most common password is password 123, if you type password 123, it is converted into a hash map, right? Which is one-way encryption. That means it's once encrypted, you cannot decrypt it back, into password 123. How do you actually know that? When I type password 123, that it is password 123 that I should compare? I convert the password 123 into the hash map that I already have in the database, which if somebody hacks, all they get is hash map. It cannot be converted back to the text. But once I convert hash map, then I can compare them to, right? And so I have original hash map, you typed in a new password, it gets converted to hash map, you compare the hash map to see, do they match, right? It's very simply put. Technically, there is a lot more to security than that. If you say that to a security consultant, they will probably whack my head and then just say, are you nuts? But I'm dumbing it down for you. The most simplest form of authentication works like that. And there are data encryption mechanisms that you need to worry about. Data in flight, then that means when data is moving through the pipe, that you have HTTPS today, right? And it's encrypted up to 256 standards. 256 is the most common standard nowadays, encryption standard. And then there is data encryption at rest, right? And then once your data is physically stored on the server, you don't want it to be stored as password 123, or any sensitive data to be stored, or any data for that matter to be stored, so that anybody can retrieve it if they have physical access to the server. You want it to be encrypted at rest. So anybody gets hold of that hard drive, let's say they yanked it out of the hardware physically and tried to plug into a different computer, all they get is a bunch of garbage, right? And you cannot read it. So all of those services are available from Amazon, right? Now let's think about deployment tools, right? When I say deployment, when you write code, you don't literally copy paste it into a folder on a server. There is a process to actually deploy it to the server, right? That actually does a bunch of things, right? CloudWatch, is actually a monitoring service for your cloud, for example, that's available from Amazon to say, hey, I want to watch my cloud so that it doesn't go down, right? And as recently as 2 days ago, all of Facebook services went down, right? And now, how do you know your service went down, right? And now it was down for 6 hours or so, right? And now your WhatsApp, your Instagram, your Facebook, all other Facebook services and connected to Oculus, and all of that went down, right? How do you know it's down? You have a CloudWatch program, right? And now Amazon offers one of those. Auto scaling, right? And I talked about one computer becoming 10 computers, and as processing power need increases, and coming down when the processing power need decreases, right? And now that's auto scaling, or elasticity of the cloud computing. That's a service that you can actually buy or rent. I shouldn't say buy. It's all renting. Cloud formation, right? And now that is provisioning, right? And now when you get a hardware, you want to make it ready, right? And now that's practically getting ready to go out, right? And now putting on the makeup and doing your hair, brushing your hair, technically that's what cloud formation is. It'll groom the computer to be ready for whatever you're going to do with it, right? And if you think about testing, there is code star, right? And a code build, code pipeline. And a code pipeline is practically useful for CI/CD processes. CI/CD is continuous integration and continuous development. You hear a lot about Agile Scrum methodologies in development today. Agile Scrum methodology relies on CI/CD pipeline to deploy the code, right? Because you're deploying the code every day, right? Every day there is a new piece of code that's being deployed. And these are not 5,000 lines of code. We're talking about millions and millions of lines of code that gets compiled, made ready to be deployed to the server, and make sure all of those services don't break, right? And that's the most important part of CI/CD. So that's on the testing front. Now, once you deploy the code, we all want to know, hey, how is it performing? It's all about analytics, right? And now you want to monitor, measure, how are you doing? Athena is actually a service from Amazon that queries and visualizes all of that information. How is your code doing? How is it performing, right? Cloud Search is actually a product from Amazon that supports 34 different languages. So imagine if you have to deploy a service, right, to all those 34 languages, you're up and running in that time, right? And if you want to do 34 language deployments without that cloud service, you're sitting for 5 or 7 or 8 years before you will have those 34 languages, because you need to have experts in those languages who knows the cultural nuances of A versus B in that language to translate all of that for you, right? So all of that's available for you. So my point being, right, long-winded answer, to understand what cloud piece to adopt, there is no one-size-fit-all answer here. You have to understand the purpose and the requirements of what are you trying to do with the computer that you are borrowing or renting, right? And you need to know that renting is pretty straightforward, right? And if you want to rent a house, you need to know how many bedrooms you need, how many bathrooms, a kitchen, how big the kitchen should be, and do you need space around the house, right? Without knowing that, how do you go about renting a house? You cannot, right? So it's the same ideology for anything that you want to rent, be it a car, be it an apartment, be it anything, right? And in America, you can practically rent anything, right? You can rent tools, you can rent cars, you can rent trucks, you can rent, pods, to move your stuff from one place to another. You name it, you can rent it, right? So is cloud, so is computer, right? And cloud is practically renting stuff, right? So now that we understand all of this, now let's talk about benefits of cloud computing, right? Benefits, starting with cost, right? Cost is actually a big factor in cloud computing, because remember, I told you, when my job actually needs 10 computers, I spin up 10 computers. When I don't need them, I spin them down, right? So when 10 computers are not running at the same time and only used when I need it, I save cost, right? And that's why cloud is impressive, right? You only pay for what you use. You don't pay for when that server is sitting idle. You don't need to pay for it, right? And you use it, you pay for it. You use the bandwidth, you communicate with that server, you pay for the bandwidth. You don't communicate with the server, you don't pay for it, right? That's the best part of cloud. Global scale and elasticity, right? And I talked about elasticity. Global scale is all about launching worldwide, right? And if I decided to have an application available in all different continents, I can do so today. In the past, I couldn't, because I will have to physically rent a data center, fly somebody to that country, put all of my data on that server, get it all up and running, and then hire some people there to maintain it. Today, I don't have to. All I have to go to Amazon's website, log in, click few buttons, select the location, and then just say, deploy it. Click one button, it gets deployed. I am up and running, right? It's that simple. Yes, there are complexities beneath it, but, technically speaking, it is that simple. Performance, right? And if I am running my own servers, and I will be limited by the number of servers I have, right? On the cloud, I have the elastic, behavior that allows me to go from 1 to 10 without blinking and bring it down to 1 when I need it, when I don't need it, right? So performance is actually a big boost, right? Security. We think, when I maintain it, or when we maintain it, security is better, right? And hey, we would like to be in control, right? Security is attached to fear. Fear, is attached to control, right? But cloud vendors rely on, experts in this industry, right? Their whole business is about managing your servers and data, so they have to be very secure. So the platforms that we use today is so secure that, hey, it has to be a hack that's happening within the network. That means somebody typed in their username and password and handed it over to somebody who is a hacker. 95% of the time, that's what happens. And then there is another 5% of the time where somebody forgot to do something right and it gets hacked. What we do as cloud companies and software as a service companies is we actually every year we I shouldn't say rent, we hire penetration test, security professionals. They are companies who are sitting there, and their job is to actually just hack your system. So we literally buy and rent hackers to hack our system, like Apple does, and Google does, and others does. We pay them for it, and when they hack the system, they tell us how they hacked it, and we patch that hole, right? So that's what all of these companies do. But if you are running it yourself, you don't have the money power to buy these hackers to test the system for you. So security, in most of the cases, it will be a few notches above what you can attain if you are maintaining the server. Speed, of course, right? And I don't have to talk about it. I talked about how scalable this is. Speed is, of course, the most important part of cloud, because everything is maintained and done for you. So you can deploy it like that, right? And it's very fast to actually get things up and running. And then, of course, with speed and all of this flexibility comes productivity. That means, when you hire employees, you're paying them by the hour, right? And productivity is important, right? And you want to make sure that, hey, if you're paying somebody, they're doing the work, right? And productivity increases because everything is up and running fast and quick. And of course, the last one, reliability, right? Cloud services are very reliable because they are maintained by professionals who understand how to actually maintain those servers at an optimum, climate, optimum serviceability, and everything else that is attached. And when you buy or rent cloud service, there's always an SLA, support level agreements, that say if the service goes down, it has to be back up in a certain time period. And if it's not within the time period, there is a big, remuneration the cloud vendor is supposed to pay the cloud renter. That means I was looking for my service that I pay for, I didn't get it. Because of that, you need to pay me some money, right? And that's always in the contract. So they always make sure reliability is actually kept up, right? And for example, I'll give you a most simple example. In the United States, when you ship a courier, we call it couriers in India. When you ship a courier, you can actually say, I want to insure the package, right? For X amount of money, right? If you insure the package, it's almost guaranteed that the package will reach the destination because it is insured. They don't want to lose an insured package. 99% of the time, they don't lose an insured package. They will get delivered. It's the same thing with the reliability for cloud computing, right? And that contract would say, you need to pay me if the service is down. It's my insurance, right? If it's down, I get money, right? And so they make sure, the cloud vendors make sure it's up and running. And the last piece, of course, is risk attached to cloud computing. The risk is, cost is a saving, cost is also a risk, because if you use the service heavily, the cost could increase, right? Because remember, it's a pay-as-you-go service. So you should actually budget it accordingly to say, if my service is going to see more usage, I better account for it and budget for that cost increase. Compliance and legal, right? To operate in a cloud and store personal information in the cloud, there are a lot of compliance and regulatory issues, right? For example, I as part of being at Arena, launched service for defense, right? We service defense sectors today. And servicing defense means, that the security of the data is prime and important. So compliance and legal is a huge burden on companies, right? So if you go to a cloud company, they already have these certifications in compliance and legal and regulatory, all of that taken care of for you. So a lot of that is automatically addressed. So the disadvantage there is, you're not controlling it. You're relying on the cloud vendor to make sure they are enforcing those compliance and legal ramifications that come out of data leaks, GDPR is actually a European regulation that you need to abide by. If somebody's personal information gets out there, you could get sued as a company. So all of that's put together, compliance and legal issues to think about. And the biggest of it is lack of control. If you give somebody else the control of maintaining your servers, you don't have control over it. You have only SLA commitments and contracts, to tell them that you're supposed to do this for me. But if they decide to do whatever they feel like, you're out of control. You don't have any control over it. So that's lack of control to think about. Security, of course, right? If you are after a certain level of security and that is not being offered by the cloud vendors, of course, you cannot attain that level of security, right? So security is also a concern, and you have to put that into your consideration when you're trying to put your stuff on the cloud. Connectivity, of course, right? Internet goes down, everything is dead on water, right? There's no point in talking about it because you can't access anything. So connectivity is important too, right? So all of that put together becomes the risks of cloud computing. Now, I will sum it back into this last slide. When it's smarter to rent than to buy, right? And that is the essence of cloud, right? You have to understand the requirements, the purpose of what you're trying to do, and then decide, should I buy the house or should I rent it? Because I'm going to be in the city only for 3 months. Buying a house is not an approach that you should go after. You should probably think about renting, right? But if I'm going to live there for the next 20 years, or whatever amount of time is reasonable for you, then you should probably think about buying, right? So in today's world, nobody buys hardware because hardware becomes obsolete, compute power becomes more, memory is becoming, larger and bigger, storage is larger and bigger. Nobody buys computers, everybody rents them, right? So once you rent it, it's not your problem. You ask for more, they give you more, right? So it's, in today's world, it's smarter to rent than to buy. And renting is equivalent to cloud computing. You just go to Amazon, Azure, all these guys, and they tell you, yeah, we can give you all of that. You just pay us for what you're using. So essentially, cloud is when it's smarter to rent than to buy. So with that, I will stop my blabbering and lecture, and we will switch to Q&A. All right, back to Hridaya.
Okay. Thank you, Mr. Anthony. It was indeed a beautiful presentation. Now, we will go ahead and take some time for the questions. Dear participants, those who have any queries can make use of the raise hand option to get the notification to unmute. You can also make use of the Q&A option to type your questions.
All right, and if you're feeling compelled with the use of English language, and you don't have to restrict to English, and you can ask me in Malayalam, and I'll be more than happy to answer you in Malayalam if you want that.
Okay, as Anthony said, Malayalam ചോദിച്ചോളൂ ട്ടോ questions.
Right.
Sir, there is a question in the chat box. What are the career opportunities in cloud computing?
Yeah, that's a wonderful question. Actually, I mean, it's one of the most important parts, right? I talked about, hey, you should always think about cloud computing because this is one of the most upcoming markets in industry, right? So let me switch to a couple of my slides, that I added at the end, and talk about careers, right? And careers in cloud computing is spread across all of these boxes, right? Infrastructure, which is the physical hardware, people who love hardware and then understand hardware can actually get into the careers in the infrastructure side of cloud. And I'll talk about all of them in the next couple of slides. If you're interested in cryptography, right, security, privacy, encryption, that's another piece of the cloud that you can get a career in, right? Cloud security engineer is a title, right? Almost every cloud company has them, right? Architecture, is another sector that you can find jobs in. If you're interested in middleware, and a lot of people call it, full stack engineers, nowadays, and that's another place to think about, right? DevOps is actually, they are the people who make things happen. I talked about continuous integration and continuous development, right? Or continuous deployment. All of that's done by DevOps. They write scripts. They make all of that seamless and continuously deploy the code, compile the code, and put that onto production. Application management is another sector, right? Like, for example, Arena is actually an application that is deployed by thousands of customers who hire administrators for those applications, right? So you can have an application management career if you chose to. Device management, that's literally going down to the hardware level, right? Managing servers, managing networks, managing routers, all of that, right? That's available too. And if you are a person who loves data, database analytics and big data, right? And that is actually another career path in the cloud that's available. There are a lot of companies that are out there in database management, analytics, and big data. It's everywhere, right? And you will find a lot of career opportunities in it. And the fundamental database management, right? The physical database management of Oracle database, Microsoft SQL Server, Postgres, you name it, all of those, are also a big career across the IT industry. All of these put together become all of the different careers that are available to you. Now, if I dive down a little into it, then I have a couple more slides and I'll talk about, so that you understand it clearly, where to find some of these, right? This is a role-based career path, right? To become a cloud architect, right? This is Microsoft Azure, right? Certification. Each of these vendors have their own certifications. So if you're a Microsoft certified, this is the path you will take to become a cloud architect, right? You learn about operating systems, because Windows and Linux boxes are mostly what's beneath Microsoft Azure cloud. And then you would learn about programming languages, Python, .NET. .NET is a Microsoft framework. Go is actually a language that's very famous in the cloud world. And SQL, of course, SQL is a language for the database. Networking, you need to understand networking and how to configure networks, how to actually make it all work, right? And then at the end, Microsoft Azure and all of those service provider specific, details. And that's how, once you understand all of this and learn and certify yourself with all of those, you become a cloud architect. That's a career path, based off of the role. Now, how does that look like on Amazon or AWS? It looks like this, right? And you start with a foundational cloud practitioner, and then you go down to associate, or go to the right, and then moving to the right, and you see cloud associate, professional, and specialty, right? Excuse me. Solutions architect, they work on solution side of the story. If you want to be a developer or a sysops, all of those, including DevOps engineer, advanced networking, big data, and security, all of those areas that I talked about have its own specific certifications to give you a career path. And a lot of these cloud companies, right? And if you go on Netflix, and if you go on Facebook, if you go on WhatsApp, if you go on YouTube, and if you go on TikTok, all these companies hire all of these areas. Every single one of them have it, right? Here's another, I'll skip through this because I just talked about it. I'll share the slides at the end. And if I just finally go to Microsoft Azure, I'm not expecting you to read it. It's an eye chart. I'm sorry, it's tiny text. But the point is, all of those vertical paths that you see is actually a certification, right? Azure developer, Azure architect, Azure data engineer, AI engineer, IoT engineer, all of that certification path. Certification paths. And all of those numbers kind of correspond to Microsoft's certifications that you can get for pursuing a career in Microsoft Azure cloud computing. And how does that compare to Google Cloud? This is how it compares to Google Cloud. It starts from the left, from the right, associate level cloud engineer and professional cloud developer, professional data engineer, and cloud architect. Google takes a much simpler approach to certifications. Google offers it directly through Google. Microsoft Azure offers it through a ton or a plethora of certifying organizations that are out there. I have included some resources so that you can actually go check them out. There are some available in India, and you should be able to get those certifications. As the last slide, here are the resources. Of course, go to YouTube, check out cloud computing. There are a ton of them that talks about where you can get certifications. Azure links are here, Amazon links. And then this is what I found as the top 10 companies that are offering certifications in India. So in a sense, a ton of opportunities. Do not discount it. This is your path to a very benefiting career as you move forward. There is no way this thing is going anywhere. This is going to stay and it's going to grow, and it's better to seize the opportunity and then take up a career in cloud. All right. I see a couple of other questions, and I'll try to answer it. How actually data get value or money? I am not quite clear on the question, but I'll see if I can answer it. If you're asking me how data is equal to money, your personal data is equal to money because they like to know, here's how Facebook makes money, right? To know, you go on Facebook and then click on like of something that you saw, right? To know, what they look at is that ad or that content, what was that content about? What was in the content? Where was that content from? And it tells you a lot about what you like immediately, right? And what was that content about? Who was the content about? Modeling, right? And somebody was wearing the fanciest new, new style of clothing that's available, or sunglasses, right? And Facebook knows that, and that ad or that picture is about sunglasses. So next thing you know, you will see a bunch of sunglasses ad, right? That's how data equals money, right? And the more Facebook and Instagram and Google know about you, the better for their ads. The ads they serve you is based off of context of who you are. That's why I said there's no free lunch. You are giving them the data, they are serving you the ads, and they are making the money out of you. All right, so is data safe in the cloud? Absolutely, right? And it is as safe as your phone or your computers or your servers, they're all safe in the cloud, right? And because like I said, they follow the most strictest security protocols that are out there. Can hacks occur? Of course, yes, right? And hacks are ways of getting your data, that was not discovered before. Somebody discovered a backdoor and got access to your data. That's why it is important to encrypt your data in flight and in rest. When I say in flight, when it's traveling through the cables. In rest, that means it is sitting on a physical hard drive in your computer or on your cloud software. So talking about is data safe? Make sure you're encrypting your phones. Android offers you that opportunity, so does iPhone. If you're not encrypted your phones, somebody who gets your phone can actually access your data. All right, those are the questions I see. Any other questions?
Anthony, one more question is there in the chat box. What are the present research areas in cloud computing?
Oh, that's interesting. There are a ton of them, right? And people are moving into other edge, computing principles, right? And there is edge that is going on. There is IoT coming in. There is augmented reality coming in. I talked about Vuforia, which is one of our products. Augmented reality is a big, area in cloud computing. Machine learning is another area in cloud computing, right? And and AI, right? And you talk about, you hear about Teslas, right? And they're driving by themselves, right? And they can drive, right? And it can maneuver between people, traffic lights, stop sign. It can turn, automatically. All of that's, research areas in cloud computing. All of that's powered by cloud computing. Virtual reality, right? Or augmented reality is an upcoming market, where, think about, if you are a technician, I give you an iPad, and then you walk into a giant machinery and you're supposed to repair it. You put up the iPad and then switch on the camera. You can literally see with a video, right, and the camera put together, what's in the machinery and what part are you supposed to replace, and fix the machinery that's not working. So that's a very practical use case of augmented reality. Now think about training use cases for augmented reality, right? Now, if you're being trained to be a pilot, I don't need a plane to train you. I can actually put you in a simulator, right? Which is augmented reality, right? Of flying a plane, landing a plane, taking off, right? A plane being in the cloud, when there is thunderstorms, right? Turbulence, right? All of that situation can be simulated and trained. Of course, they need live training. That's a different story, but I'm just giving you an example of all of those areas that benefits from cloud. And a lot of research goes into augmented reality, machine learning. Machine learning is all about being able to, feed an algorithm a bunch of raw data, and then it learns from it. And then next time you show it, so think about an example, right? In the simplest form, you feed an algorithm a bunch of cat pictures, right? And then the next time you actually show it a cat picture, it knows that it is a cat, right? And even if it is, obscured, it can detect that it's a cat. And that's machine, learning, right? And the machine learns from a bunch of data that you gave it, right? And then it starts evolving. It actually knows cat in all the different forms, as and when it detects more pictures, it starts learning more and more. That it's like you and me, right? When we were kids, we knew, somebody told you a cat is a cat. From next time, you saw a cat, you can recognize a cat. Think about the same thing, a machine will do for you, right? And it's beneficial in a lot of places where image recognition is important, right? And think about quality in a manufacturing scenario where, machines are minting some product, right? And so they take pictures with video cameras to make sure the product is complete and it's full quality, right? And as they take pictures, machine learns from the pictures and then says, hey, wait a second, that bottle that came out of the manufacturing doesn't have a lid on or a cap on, right? And you don't want a Coke bottle without a lid, do you, right? So that's machine learning at work for you, right? And it's all powered by cloud computing.
Okay.
All right. Any other questions?
One more question is there in the chat box. Okay, that is, can we save all data in cloud? That is the question.
Yeah, so you can, right? If you think about it, Netflix is about video, right? Microsoft Office is about PowerPoints, Word documents, Excel sheets, Google Suite is about the same thing, right? And Instagram is about pictures and videos, TikTok is about videos. So you name it, if it is a computer generated data, you can store it in the cloud.
Okay, any other questions from participants?
Anthony, I'm Ramya.
Mm-hmm.
I would like to ask one question. How do government agencies adopt cloud?
That's a very good question. It goes through a rigorous process called vetting, right? And government agencies usually have strict protocols for adopting cloud because they are giving their data and storing it on some server sitting somewhere else, which they don't control. So encryption and security is prime and center for government agencies. So they go through a very rigorous certification process. I talked about American standard. I don't know Indian standards, but American standards are here. They are called ITAR and FedRAMP. right? And now these are applied by America to actually adopt cloud. Before they adopt cloud, they have 114 specific requirements plus another 20 security requirements, and few regulatory requirements as well. So altogether, 140 requirements have to be met before they will adopt your cloud. And they are not trivial. They're very, very rigorous process. They will audit you. They have the control because they are government.
Anthony?
You know?
Anthony, your
Yes. Can you hear me? That's interesting. Can you hear me? Uh-oh. Can you hear me?
Yes, sir, you're audible.
Okay, good, great. I'm sorry, I don't know what happened there. You know, it could be me, it could be something else. And hey, like I said, internet is essential to cloud. I don't know if you can hear me, but you know, it looks like there is one more question that showed up. Storing the hash of the data in the blockchain actually is more secure. Is it more secure, sir? Blockchain is actually, I don't want to say it's more secure or less secure. It's a different technology. You know, it allows you to actually have connecting chains validate whether one of the chain link is correct, and that's the biggest advantage of being in a blockchain. It's a webinar in itself, so I will leave it at that. It is not a bad idea to use blockchain to create secure services, but there are other technologies that allow you to do that as well. But another webinar, I can talk about it. So if you can save all of the data in the cloud, personal details save ചെയ്താൽ machine learning കൊണ്ട് എവിടെയെങ്കിലും നമ്മളെ identify ചെയ്യാൻ പറ്റും. Yes, of course, right? To know there are countries, I'm not going to name the countries, and I don't want anybody actually blaming me for it, but I've been to countries where every step of the way your picture is taken, right? And you're on the street, you're driving, camera goes off, they take a picture of you. There are countries, well, why am I shying away, right? There is actually a renowned journalist who went to China and tried to hide, and guess how long he lasted? He lasted all of 7 minutes before they found him. So that's how heavy AI and cameras are used in China. So essentially, if you put your data, anywhere, right? They will be able to use it, to identify you. So there's no escaping that, right? Directly putting the data is one thing. Indirectly putting the data is another thing, right? I can actually ask, Abhinant, your question is very valid. I can ask, your neighbor, a little data about you, and another neighbor who knows you and a little more data about you. That's called social engineering. And, so is machine learning. So what it does is, Google is very good at this, right? It actually formulates a map of who you are, right? So does Facebook. Facebook has got a feature, whereas it's in your Facebook account, you can go download the data about you, right? And go download the data about you and be astonished and surprised how much Facebook knows about you, right? And it will tell you your interests, it'll tell you who you are, who your relationships are, things you like, things you don't like, things you care about. It'll tell you all of that. Google has got a big map about you. The whole premise of offering you Android for free is to make sure they can get the data out of you without you knowing about it, right? Gmail, everyone uses Gmail. What do you think happens to the emails that go in Gmail? They are actually indexing all of that, right? And they are formulating a map about you, right? When you buy a package from Amazon, an email shows up. When you buy a package from Flipkart, an email shows up. They know you bought it. They know that you like that, right? Now, if you buy that repeatedly, then they know even more that you repeatedly buy these products, right? And so that's called a map of who you are, and they all construct that map.
Okay. Any other questions from the participants?
Anthony,
Mm-hmm.
your presentation was wonderful. And I personally thank you for finding some time in your busy schedule.
You're welcome.
And I have a question to you. Is cloud safe and secure for personal information? And how do vendors charge for cloud services?
What was that? What was the last part?
How do vendors charge for cloud services?
Oh, okay. Yes. So a couple of questions in there, right? And one is it safe for personal data? Yes, it is. It is generally safe for personal data. We store our data in Facebook and Instagrams and others, right? In Gmails, so it has to be secure, right? So that's very known. It's encrypted. It's available as needed, but you can almost rely on it without any trouble. The second part of it is, how do cloud vendors charge for it? It is a pay-as-you-go service. Every cloud vendor charges you for what you use. They don't charge you for if you don't use it, right? So let's say you decided to get EC2 from Amazon and then some S3 service from Amazon. There's going to be some baseline, charge they will charge you, because they need to provision and then get all of that up and running for you. But from that point forward, it is as you use it. But that use is for everything, right? And you think about it, they will charge you for it, right? And cloud computing power, they charge you for it. Bandwidth up and down, that means sending a request, you get charged. Sending that request reply comes to you, that'll get charged. Storage, you will get charged. So it's practically a metered service. Everything is metered, right? It's like your water or electricity bill, right? And everything you use, you pay for it, right? And that's how cloud works.
Okay.
All right.
Any more questions from participants? Okay, then I'll ask a last question, Anthony. Okay, what type of applications can run in the cloud? Can you tell that?
Practically everything can run in the cloud. It's all about putting them in the right virtualization and right containers. When I say containers, I talked about Docker, right? And the Docker is a containerization mechanism. Any kind of application can be put in the cloud. Any application that you have on your PC can be put on a remote PC, right? And a cloud is a remote PC that you have access to. It isn't just not your laptop, that's about it. So you take any application, you can host it on a cloud. And I think, there was another question from Randeep. Will they sell our data? It depends. You got to read the fine print of terms of service. When you sign up for a service, there is this big legal document they show you. And it's somewhere in there, there will be a language that says, we have the right to actually use your data for whatever purposes. And if it says so, yeah, they will sell your data, right? And no, and it's practically in the legal that you sign. Like most of you would not even bother to read it because you just when you get the app, the first page that comes up is, do you agree or cancel? If you don't agree, you cannot use the app, right? And so you just click on agree, right? And without even reading it. But somewhere in there, they will say, we might sell your data, right? Data brokering is actually a big business, right? And everyone does it. Your data provider, right? Whoever is providing your data connection to your phone sells your internet browsing history, right? They make money out of it, right? That's how Google, that's how Facebook, that's how Flipkart and others find out what are you searching on the internet, right? They transfer that data to Google and others. They buy that data. Any internet provider, because they are the ones who are serving you the internet. They know what websites you visit. They sell that data, right? The industries that don't usually sell the data is banking, if it is regulated and controlled, because you're not supposed to sell the data. And if they are caught selling the data, that's not going to be fun for the bank, right? And then of course, governments that usually are not in the business of selling data, but they are in the business of governing people, so they don't sell data. But all other private companies, they are in the business of being in the business, making money, right? And so they will do whatever it takes to make the money, right? And Facebook, Google, all these guys, they don't sell data, but they use data to their advantage, which is selling you ads. That shoe that you're looking at, that keeps showing up in your Facebook, ads. It's because they know that, you looked at that shoe, right? Or you looked at that little new shirt, or you looked at that new necklace, and it keeps popping up back in your Facebook ad. And what they're trying to do is ads do this subconscious thing of actually trying to make you buy it. They show it to you more often. Eventually you'll break down and then buy it because you have seen it so often. And it's a science. I'm not making that up. It is true, proven, it's a science. And that's why when you watch TV, when an ad shows up, it's louder than the TV content. You can watch it and then tell me that it's wrong, but it's not. When you watch TV, you're playing it at, I don't know, 10 level volume. The ad shows up, it's at 13. It's loud. It's because they want you to pay attention. So there you go. Everyone's in the business of selling you something, and there's no free lunch again. All right, I don't see any more questions. Good questions, by the way. You guys are an active crowd. I like that. All right.
Okay. So it looks like we have covered all of your questions from participant side. So Mr. Anthony, is there anything else you wanted to cover before wrap up?
No, I think, I covered everything, practically look up the resources if you're interested in cloud. This is a good career to follow. And by the end of the day, if you are picking up something in the cloud, you should get some certifications. It is important to get the certifications because that gives you the baseline of learning what cloud is all about. I've only covered the foundation. There is every single aspect of the cloud that I talked about is worth weeks of a class, right? There is a lot more to learn and understand the depths of it. I don't know all of it. No, I just generally know what cloud is because I'm a product designer on cloud. And I manage a bunch of people who produce products on cloud. But there's a lot more to learn, right? Technically, there is quite a bit of depth to cloud computing. So get certifications, if you are thinking about a career in cloud. All right.
Okay. Okay, Anthony. Then It was really an interesting topic, and Mr. Anthony started with the evolution of clouds, and he went on to the definition and components, and he ended up with the benefits and risks of it. So we really enjoyed the session. Thank you, Mr. Anthony. Now, I would like to invite Ms. Demia K, the Assistant Professor of Department of Computer Science, to deliver the vote of thanks. Over to you, Ms. Demia.
Thank you, Hridya. Honorable Resource Person, Anthony John, Principal Dr. C.P. Sujesh, IQAC Coordinator, Dr. Shaji Maram Vitit, Program Coordinator, Sri A.M. Abdul Salam, and all other participants of this session. A warm good morning to all. Now we have come to an end of our third technical session, and it was indeed a wonderful seminar on cloud computing by Mr. Anthony. During the session, he have given an insight and knowledge regarding clouds. Now, let me move to express my gratitude to our resource person, Anthony John, who have shared with us a very informative session. Thank you, Anthony, for sharing your time with us. A special thanks to our principal, Dr. C.P. Sujesh, our IQAC coordinator, Dr. Shaji Mara Vitil, program coordinator, Sri A.M. Abdul Salam, for providing immense support to us. I am thankful to all our teachers, students, and other participants who have gathered here. Thank you. Thank you once again.
All right.
The meeting is discussed.
Thank you, everyone.
And
Thank